Islands of plastic floating in the ocean, some as big as the state of Texas. Linda, unbelievable, isn't it?
Bigger than the state of Texas. The graphic was 2 times the state, and when I did this interview, they now say 3 times the state of Texas, right? And a report in the journal Nature was entitled, Evidence that the Great Pacific Garbage Patch is Rapidly Accumulating Plastic. The research was done by the Ocean Cleanup, led by its founder and CEO, Boyan Slat, in collaboration with 14 other marine scientists. Everyone was stunned to find that the Great Ocean Garbage Patch equaled 620,000 square miles. It's about 80,000 tons of plastic trash, which was up to 16 times larger in size than had previously been reported. And the graphic is gone from 2 to 3 times the size of Texas and continuing to grow and expand between Hawaii and California. That's where it is. The plastic trash and other garbage in the Pacific is expected to keep increasing at least 2% each year unless something is done to clean it up. According to the United Nations Environment Program, the Earth's global population in 2016 was more than 7 billion people who have been producing and throwing away every year 300 million tons of plastic. That huge number is expected to keep growing, and so UNEP warns that by 2050, there will be more plastic than fish in the world's oceans. Humans in 2018 are now using more than 320 million tons of plastic. The number has gone up. And 2/3 of all plastic is less dense than seawater, so it floats on the ocean surface. When people use the ocean as a trash dump, lots of the plastic stays afloat and moves in the ocean currents, piling up where the waters naturally spiral in these massive vortexes that are called gyres. Eventually, with storms and tides, the plastic garbage washes ashore, covering once clean beaches. And you can see some of those depressing photographs at Earth Files. They actually need to be seen to be believed. Floating at the surface of the Great Pacific Garbage Patch are lots of plastic nets that have been discarded by fishermen, and they're called ghost nets because they're still out there, and they're catching turtles and fish and everything that is innocent and killing them. The Ocean Cleanup research reported that nearly half, 46%, of the plastic mass in the Pacific Ocean are ghost nets that are constantly entangling marine creatures, and that's what plunges them to their death. Sea turtles can eat as much as 74% dry weight of their diets from plastic trash in the oceans. But the plastic just fills up their stomachs, killing the turtles either by starvation or poisons from toxic ingredients in the plastics. Investigations have confirmed that 84% of plastic floating on the ocean surface is found to have at least one toxic chemical. The founder and CEO of the Ocean Cleanup has worried about the growing plastic garbage problem since he was 16 years old. He was scuba diving in Greece, and he came across more plastic bags than fish. He started asking, why can't we clean this up? That question led to the current full-time career that Boyan Slat now has at age 23. Boyan's goal is to first test a system to remove discarded fishing gear and nets. He plans to get a fleet of 60 cleanup systems operating full-time. He estimates if they all work, he could remove half of the Great Pacific Garbage Patch every 5 years for the foreseeable future. Here now from the Netherlands Ocean Cleanup is Boyan Slat.
What we found was that there's 16 times more plastic in this patch. There are 1.8 trillion pieces of plastic in an area twice the size of Texas. It's continuing to grow, and it doesn't go away by itself. And there's really 3 problems with having this plastic in the ocean. First of all, it's disastrous for marine life. So right now there are around 800 species that could go extinct because of this plastic pollution. Then we have the economic impact. The United Nations estimates that there's around $13 billion of damage being done by plastic pollution every year to tourism and to fisheries and other industries. And finally, what happens is that this plastic breaks down into these smaller and smaller pieces, microplastics. And the thing is that those tiny pieces, they attract chemicals to them. And when fish and other marine life eats these plastic, it eventually ends up the fish on our dinner plates and thereby causing potential health impacts as well.
Could you help us all understand how there could be a growth to 1.8 trillion pieces of plastic and a garbage dump in the Pacific Ocean that is 16 times larger than anyone thought? How is this possible?
Yeah, so the problem that we see in the ocean garbage patch is an accumulation of damage being done over the past 60 years. Ever since we started using plastic on a large scale after the Second World War, plastic ended up on the streets and maybe then into rivers, and then from rivers into the ocean. And the amount of plastic increased, and hence the amount of plastic in the ocean is also increasing. And the reason why we have these ocean garbage patches is because there are 5 areas in the world where ocean currents converge. So they act like the sink of your bathtub, and the plastic wants to concentrate in those areas. Once the plastic is in there, it doesn't go away by itself. And the only way to get that concentration down again is by going out there and cleaning it up.
Well, what hits me from what I have been reading is, why wasn't there more of an aggressive attempt to clean up the plastic 10 years, 15 years ago, when it seems that it would be clear that plastic accumulating in the ocean would be a threat to marine life?
Yeah, that's a good question. So definitely the amount of knowledge on the problem has increased a lot. Our work has also been part of that. But on the other hand, there have been ideas in the past to go out to clean up, but they were based on ideas where one would use boats and nets to go out and fish for plastic. But the thing is, although there's a lot of plastic, it's spread out over this vast area, meaning that it would take tens of thousands of years to clean up just one of those patches if you were to go fishing for plastic. Really, the key in the technology that we have developed is that instead of going after the plastic, we let the plastic come to us. So we use very long floating barriers to let the ocean currents do the hard work for us, to first concentrate the plastic before we take it out. I think that has really been making a difference. So what I found over the past few years is that there's not a lack of will to clean this up. People really want to see this thing go away, but it was simply that the technology wasn't there to do it, and that's what we've been developing.
But how do you get the plastic that is gathered in the equipment? How do you get it into something that takes it away in bulk? And what are you using? Can you describe the whole process?
Yeah. So to use an analogy, you have a park that's full with leaves. If you were to pick up those leaves one by one, it would take a very long time. But if you have a leaf blower, then first blow all the leaves on the central pile and then pick up the pile of leaves, then it's easy to remove the leaves from that park. So in a similar thing is the approach that we're using for the ocean. So instead of leaf blowers, we use these cleanup systems. They concentrate the plastic, but once it's concentrated in those U-shaped, funnel-shaped devices that sort of go around like a Pac-Man and concentrate the plastic, sort of once the plastic is in there, then it's very easy to get it out. And the technique that we are using with this first system that we're launching this summer, we're putting a very fine mesh net around the clouds. Every 2 months when a boat comes, we put that around this cloud of plastic that is in this cleanup system. And then we close the top, we close the bottom, we make sure there's no marine life in it, and then we simply lift it up to the crane. So you'd have this bag full of plastic suspended, and then we put it on the boat, and then the boat takes it to land for recycling.
How long is it going to take your process to get rid of this 1.8 trillion pieces of plastic?
So with a fleet of 60 cleanup systems, we estimate we should be able to remove half the Great Pacific Garbage Patch every 5 years.
Is it being added to exponentially?
Sure. So we still see an increase of plastic coming into the ocean. To solve this problem, two things need to happen. On one hand, we need to deal with the legacy, the stuff that's already in the ocean. But on the other hand, we also prevent more plastic from entering the oceans in the first place, because otherwise, maybe in 50 years, we have to start all over again.
In the past week, there was an article that has made worldwide news. The headlines are generally saying, sperm whale swallows 64 pounds of trash and dies of gastric shock. Could you explain what happened to this sperm whale, young and vigorous, and how it is a symbol of all the marine life of what we're up against?
Yeah, marine species, they mistake plastic for food, then they consume it, the stomach gets full, which causes these whales to starve to death. This is not just a single example. I think every few months or so you see an article like that from all over the world. I think it's a striking example of the impact of plastic pollution.
This sperm whale that swallowed 64 pounds of plastic and trash and dies of gastric shock, he was killed by his own intestines not being able to eliminate all that plastic that would not break down inside of his gut, and therefore he would be overcome by fungi and bacteria.
Right.
Do you have a statistic on how many whales, seals, all of the marine creatures are dying each year now from the syndrome of consuming so much plastic?
Yeah, the statistics say that around 300,000 marine mammals and 1 million seabirds each year die of this phenomenon.
Eating plastic.
Correct.
And what is the size of this huge patch now?
3 times the size of France, 4 times the size of California. I think the diameter, the most concentrated area, is roughly 500 miles.
If you were not trying to do the ocean cleanup now, and no one did, what do you think the consequences would be in 10 years if this Pacific patch continued to grow at the rate it is? And what kind of impact would it have on ocean life?
The patch will continue to grow and more species would get affected. And I think the most worrying thing is that 92% of the plastics are large objects, but over the next few decades, what is going to happen is that all those large objects will fragment down into these very hazardous and hard to clean up microplastics, which would magnify the problem. So we look at this problem as being a ticking time bomb. If we don't clean it up, then all that large stuff will become microplastics too, and then we have a much bigger problem that will be much harder to clean up.
And what happens with microbeads inside of marine life?
Yes, the smaller they get, the more prone they are to ingestion. So the more it looks like food to marine life, and it can have many effects. Chemicals leaching out of the plastic into the marine life. We have the penetration of the stomach wall, starvation because their stomachs can be full of plastic.
By 2030, that's only 12 years from now, if you weren't doing anything, it would have continued to grow. But even with the process that you have now, is it simply going to try to keep up with growth?
Yeah, so the 50% and 5-year reduction that we're aiming for, in that we actually account for new plastics. So we can get it out of the patch much faster than it flows into the patch. But ideally, we also stop new plastic entering the ocean.
But if it doesn't work out, what would your projection be for the fate of marine life and the oceans if no one gets on top of this.
Yeah, there's what some people call the sixth extinction event, where we see that the rate of species extinctions is many times higher than the natural background rate, and that would probably accelerate into the future. But again, I'm optimistic that we would be able to turn the tide.
What a story.
Oh, I sure hope that he is going to be able to prove this summer that he's got a process that is going to be taking out plastic in bulk. And there is another ray of light. Scientists have reported the discovery of an enzyme in bacteria. It was found completely by accident in a Japanese waste dump. And this bacteria that has been discovered can break down plastic drinking bottles. This is one of the big problems in the ocean. Now, these researchers at the University of Portsmouth in the UK, they They took this enzyme that they were noticing some aspects about being able to disintegrate the plastic, and they manipulated them even further. And then tests showed that they had, by accident, made the molecule even better at breaking down the plastic used for soft drink bottles. So this Professor John McGeehan at the University of Portsmouth told reporters this month, quote, "What actually turned out was we improved the enzyme, which was a bit of a shock. It's great and a real finding. What we are hoping to do is use this enzyme to turn this plastic back into its original components," close quote. And what that means, the scientists think that they can recycle the chemicals broken down by the bacterial enzyme back into making plastic, sort of ebbing back and forth from chemicals to plastics back to chemicals by using this enzyme. Theoretically, that would reduce the amount of plastic in the environment. The shocking statistic is that 1 million plastic bottles are sold every minute around the world, and only 14% are recycled.
This stuff sticks together like magnets.
Yeah, and so many of these plastic bottles end up in the oceans. They are piling up on these once beautiful beaches. They are killing the marine life, and it has to stop if we care about this planet.
Galaxies and black holes. Linda, take it away.
Well, no human has yet photographed a black hole in this universe. First, it seemed impossible if black holes grab everything around them, including light, and don't even let the photons out that could reach an Earth telescope camera. Physicist Albert Einstein couldn't see them either, but his mathematical calculations about gravity curving and stretching space-time produced the concept of mysterious black holes throughout this universe that have a singularity at their center where all surrounding mass is crushed by gravity to a single point. Before that annihilation zone, there is another place surrounding a black hole called the event horizon. Einstein said that all matter, even photons, that cross the event horizon will disappear from this universe. But before that happens, it is possible for gases and matter to orbit a black hole without falling in, and that's called the accretion disk. That's the last stop outside the strong gravitational pull of black holes where photons can escape back to our telescopes and cameras. And right at the center of our Milky Way galaxy is a supermassive black hole, about 4.5 million times the mass of our sun. It's called Sagittarius A. And now in 2018, a group of astrophysicists and astronomers are working for the first time to get an actual image of our Milky Way's black hole, or at least a shadow of its event horizon, a shadow that would be cast onto the accretion disk of gas and dust that orbits the black hole without falling into it. And to get that actual black hole shadow image, scientists are constructing an array of radio telescopes and very long baseline interferometry stations around our whole planet. It's called the Event Horizon Telescope, and this will be the first human-made technology that is the size of our whole Earth. Ironically, there would be nothing to photograph if the supermassive black hole did not curve space-time so strongly that scientists say it should be possible to see parts of the accretion disk behind the black hole. Think of a fun mirror at a carnival. There is a warping here because of this bending of space-time, and that's what they're counting on to be able to see some of this shadow cast onto the accretion disk. Further, Earth scientists need an event horizon big enough to see from Earth. The Milky Way's central black hole at 4.5 million times the mass of our sun, and our sun is 864,337 miles in diameter. So that would mean that the supermassive black hole at the center of our Milky Way galaxy is about the size of our entire solar system. So that means the shadow it casts on the accretion disk of gas and dust should be big enough for the new Earth-sized Event Horizon Telescope to actually see. But the challenge is a bit like trying to make an image of a quarter coin in Los Angeles from a camera in New York City, from one end of the country to the other. That's the metaphor for the challenge of getting this photo. Well, when computer models are run to calculate what the first ever black hole image could look like, the result is a toroidal ring of ionized matter. And if all goes well, we might all be able to see how accurate the computer projections have been. By the end of this year, we could have the first image of at least the toroidal glow and the shadow of the black hole cast on the accretion disk. And collaborating with the Event Horizon Telescope investigators is astrophysicist Michael Johnson, Ph.D., at Harvard-Smithsonian Center for Astrophysics in Cambridge, Massachusetts. Professor Johnson says it is now considered a fact that every galaxy in our universe has a black hole at its center. And he is enthusiastic about finally seeing the first image of light bent by the strong gravity of the Milky Way's supermassive black hole. Recently, I talked with Professor Johnson about his Event Horizon Telescope work and other black hole mysteries. And here he is now from Harvard University in Cambridge, Massachusetts.
I'm part of this group now that's trying to take a picture of a black hole and to see what one would actually look like. These are observations in the near infrared. It turns out that the material falling into a black hole becomes so hot, it's emitting lots of light, and the light is bent by the gravity of the black hole. It's expected to be bent into a ring shape that's surrounding the shadow cast by the black hole on the emission. So that's what we're trying to take a picture of.
Like a torus?
Yeah, it'll look sort of like a crescent moon, we think, is one possibility.
You would be taking this photograph in a very specific wavelength of infrared?
This would actually be taken at a little bit longer wavelength of about 1.3 millimeters, and using a telescope that's effectively the size of the Earth called the Event Horizon Telescope.
Right. When do you think that you might have the first image of a black hole?
Well, we don't know. I mean, a big part of the difficulty is we don't yet know what we're going to see. We're hoping that in the next year or two that we'll have these first images. We think that every galaxy does harbor a black hole at its center. Larger galaxies have larger black holes in them.
And if so, why?
The best evidence really comes from our own galactic center, and in our own galactic center, we can actually see stars orbiting the black hole. And the tightest star orbits have periods of just more than a decade or so. We've actually now traced out their orbits. They take an entire loop around this black hole, and you see this bright stars moving around something that appears not to exist. It's remarkable.
It seems so paradoxical that throughout the universe, that the matter worlds, the matter galaxies, would be married to something that annihilates matter at its center.
Black holes don't annihilate matter. I mean, if matter falls into a black hole, it becomes part of the black hole, and it will increase the mass of the black hole by the amount of mass that the object had when it was sitting outside. It's not that they're destroying matter. They're just condensing it down to the singularity. But then that action of the black hole and its continued interaction with the matter is an important part in the life cycle of a galaxy.
Once that matter goes into a black hole, if I'm understanding correctly, it's never supposed to come out, at least in this universe, that is being absorbed by the black hole.
That's right.
Well, can you explain what you think is the reason for this marriage between black holes at the center of every galaxy in the universe? Why are there black holes at all?
Black holes are sort of an end point where you can pour material in and you can't pull that back out. It's counterintuitive, and it's something that you wouldn't predict from Newtonian gravity. This is a concept that arises in the theory of general relativity, where there aren't gravitational forces anymore, but all that happens is that mass curves space-time. And so this is a consequence of how mass curves space-time and how light is affected and how the motion of material near a black hole is affected.
If you were taking the position of God in the sense of that which is incomprehensible, that which there has to be a source for this matter universe, why would you have created a universe in which there has to be a black hole at the center of every galaxy?
Well, I don't think there has to be a black hole at the center of every galaxy. If you were God and you could just paint a galaxy however you like it, you could certainly start one off that has no black hole in it. You could just fill it with stars and fill it with planets and let it go. And over time, what you would see is that it would tend to form black holes. As the stars lived and died, some of them would collapse down to black holes. And as the material accreted towards the center of the galaxy, the material could eventually become a black hole. So it's sort of a natural endpoint of this gravitational collapse.
If I'm understanding, the very nature of having large masses of things like stars, and that the star itself has a life and death cycle, all the stars do, that it is the collapse of the ability to remain being a star, and that big collapse of the gravitational forces pulling on the matter of the star end up compressing it, and that in the compression there is the creation of a black hole.
That's exactly right. Normal material doesn't just collapse down to a black hole because it's held up by its own internal structure. For some materials, that can be quite strong. But if you pile enough material on, eventually it'll collapse down. Stars are held up by the heat that's being produced at the core of the star as they're driving fusion. But if they run out of fuel to drive that fusion, they don't have that heat source anymore, and so it'll collapse down. And then as you collapse down smaller and smaller, that's when it's held up by these quantum mechanical effects, and eventually those even lose to gravity, and that's when it'll collapse down small enough to become a black hole.
So do you think that at the beginning of the singularity, that is a big mystery itself, and the evolution of hydrogen and helium and onward into matter and other elements, that the black hole came into existence only after there had been stars created?
Right. For the black holes that we're studying today, they probably came into existence long after the first stars formed.
We wouldn't have black holes if there weren't stars, and that it is the first existence after the singularity of stars evolving into galaxies that then set up some kind of dance with gravity, that when the stars die, there is going to be a compression that will automatically lead to a black hole.
Yeah, the death of a star is maybe the simplest pathway to forming a black hole. There are other ways to make a black hole, but a collapse of a star is one of the ways where you can be really sure for certain types of stars that the end result of that will be a black hole.
Can there be periodic pulses of energy from the Milky Way galaxy's big black hole at the center?
In certain ways, we might expect to see periodic pulses associated with the black hole. One would be if you had some hot region in the plasma near the black hole, it's going to be orbiting around the black hole. And that's because it's actually very difficult to fall into a black hole, kind of paradoxical. It's one of these deep mysteries associated with black holes, which is how does matter fall in? The reason that's hard is for the same reason that we don't just fall into the sun. We sit on an orbit around the sun. And that's because the Earth has angular momentum. And so if the Earth were to fall into the sun, we would have to give that angular momentum to another object so that we could fall inward. Likewise, for material that's around a black hole, it won't just plunge into the black hole unless it's very close. It'll normally just sit there on a circular orbit. And so there has to be some mechanism that drives material into the black hole.
What is that mechanism?
So this was a mystery for a long time, and now we think that the mechanism that allows black holes to eat is turbulence that's driven by a magnetic instability in the material near a black hole. We think that it's sort of tangled magnetic fields near the black hole that are providing the friction that allows the material to transfer its angular momentum so that some of it can fall into the black hole.
Okay, so if the black holes throughout the universe are eating whatever matter happens to get past that rim, is it possible for the black holes to burp out energy and might relate to periodic cycles of extinction or strange moments in our past where there appears to have been maybe big floods or big fires or something that might be related to cycles between the black hole and the Milky Way galaxy?
There are two parts to the answer to that question. The first is material falling towards a black hole can be ejected from the black hole as long as it hasn't crossed the event horizon. So it can be falling inward, and maybe it's changing some of its gravitational energy and the heat as it's falling inward, lighting up. This is why the centers of galaxies can be very bright. But black holes also tend to launch these very powerful jets. So material might fall inward, and then it can get launched out in a different direction, carrying quite a lot of energy. And that can happen as long as it hasn't actually fallen into the black hole.
What is the event horizon?
The event horizon is a special place in space-time that delineates whether or not material has transitioned to this region where nothing can escape, not even light.
Okay, what is currently the theoretical perspective on once it has passed the event horizon? Where is the matter and the energy ending up?
Right, that's a very deep question. And from the perspective of an observer like us sitting outside the black hole, there are lots of equivalent ways of answering that question that all lead to the same predictions. So the problem is you can have different ideas about what happens there, but those differences wouldn't actually affect any experiment that we could design to study it outside the black hole.
What do you think?
I choose not to speculate on those things.
What do you think would happen if we built a drone probe to go into a black hole?
Well, if the probe could communicate with us, it could send us lots of information as it was falling into the black hole. And as it got closer to the event horizon, the information that it would get to us would be stretched out in time. So we'd sort of get less and less information until it finally crossed the event horizon, and at that point we would stop receiving any transmissions.
And in the science journal Nature, they featured new research of X-ray observations that have revealed a dozen stellar mass black holes at the center of our Milky Way galaxy. And the implication from this research is there could be 10,000 more black holes at the center of the Milky Way galaxy yet to be confirmed.
It's almost unimaginable.
Yes. It is, but for the very first time in this interview, what I have understood is the very fact that we are now in a 13.9 billion year long universe, that it has had all these phases for stars to be born and then to die, and that the collapse of stars is automatically going to create black holes, and the black holes accrete. And that's why they would be at the middle of all the galaxies.
And one day we'll have a dark, dead universe.